Hey everyone! In this video we're going to go over section 4.5, factoring trinomials. This time they're going to be of the form ax squared plus bx plus c, and the leading coefficient a is going to be something other than positive or negative 1. So we're going to be factoring trinomials that look like 12x squared plus 23x plus 10. And in order to factor these trinomials, we are going to discuss the AC method, which is really factoring by grouping. So let's work out this example. Let's say we wanted to factor 12x squared plus 23x plus 10. So the start of these problems are going to be the exact same as the start of the problems in section 4.4, where we're going to multiply the first number times the second number. It's where the AC method comes from. We're multiplying A and C. So just like before, we're going to take the leading coefficient and the constant term and multiply them together. 12 times 10 is 120. And now, just like before, we're looking for numbers that multiply to 120 but add to 23. So the factors of 120 are 1 and 120, 2 and 60, 3 and 40, 4 and 30, 5 and 24, we've got 6 and 20, 7 won't go, 8 won't go, 8 times 15, which when you add 8 and 15, that is equal to 23. So we have found the numbers that we're after, 8 and 15. This is where the method is different. Now we're going to factor by grouping. You have two different ways of setting up this problem, and it all boils down to the way we write 23. We know that 23 is equal to 8 plus 15, but 23 is also equal to 15 plus 8. It's subtle, but this is important, because the next step is we're going to take this trinomial and we're going to rewrite it. And there's two different ways we can rewrite it. I'm going to show you what it looks like when it works, what it looks like when it doesn't. So let's rewrite this polynomial. 12x squared plus, and what we're going to do is we're going to rewrite 23x as, we'll do the top one, 8x plus 15x plus 10, just plus 10. So all we've done is we have rewritten the trinomial, and we have rewritten the middle term as the sum of 8 and 15. Now we want to factor by grouping. I'm going to group the first two terms together and the second two terms together. Now, you want to factor out the largest possible factor that is common to both of these terms. So we've got a 12x squared and we've got an 8x. I can actually pull a 4x out of both of these terms. If I pull a 4x out, that would leave us with 3x plus 2. This plus sign is going to drop. And we do the same thing with these two terms. Well, I can pull a 5 out of both of these terms, so let's do that. And then what's left over? Well, I'd have a 3x plus 2. Now we've got two terms. We've got this term, 4x times 3x plus 2, and this term, 5 times 3x plus 2. Notice how both of these terms have a common factor, this 3x plus 2. we're going to factor out this common factor. So, out of both of these terms, I'm going to pull a 3x plus 2. And then, we have to write what's left over. Well, if I pull a 3x plus 2 out of a 4x times 3x plus 2, the only thing that's left over is the 4x. This plus sign is going to drop. This plus sign is still that plus sign. And then if I pull a 3x plus 2 out of a 5 times 3x plus 2, the only thing that's left over is that 5. And we have successfully factored this trinomial into these two factors. We could multiply them out. 3x times 4x would give us that 12x squared plus 15x plus 8x. 15 and 8 is 23, and then 2 times 5 is 10. But like I said, there were two different steps. We could have rewritten this trinomial as 12x squared plus 8x plus 15x plus 10, or we could have rewritten it as 12x squared plus 15x plus 8x plus 10. So what happens if you set the problem up this way? Well, we're still going to go through the same steps. You want to group the first two terms and the second two terms. And now you want to ask yourself, well, what is the largest thing we can pull out of either of these terms? Well, I could pull a 3x out. So let's do that. That would leave a 4x plus 5. Similarly, what could we pull? And this plus sign is going to drop down. What can we pull out that's common in both of these terms? Well, I could pull a 2 out of each of them, and that would leave a 4x plus 5. And now we go, well, what's common? Both of these terms have this 4x plus 5, so let's factor it out. This one right here, and this one went along with it. And now, what's left over? We're going to have this 3x, hey Hooper, 3x, this plus sign is going to drop, and we're going to have a plus 2. You can multiply in any order you want to, so these two factors are algebraically equivalent. They are the same. So yeah, it didn't matter if we wrote the 8x plus 15x or 15x plus 8x. We grouped the first two terms together, we factored out what was common, we grouped the second two terms together, we factored out what was common, and then we factored out what was common again. Same method up to this step. Now we just have to factor by grouping. So let's do another example. Let's factor 3x squared plus 10x minus 8. Okay, so we want to do the first number times the last number. 3 times negative 8 gives us a negative 24. And now we're looking for the factors of negative 24. Well, that can be a 1 and a negative 24. That can be a 2 and a negative 12. That can be a 3 and a negative 8. That can be a 4 and a negative 6. 5 doesn't go in there, 6 does. We can do a 6 and a negative 4. We can do an 8 and a negative 3. We can do a 12 and a negative 2, and a 24 and a negative 1. We go through. 1 take away 4 is negative 23. 2 take away 12 is negative 10. 3 take away 8 is equal to a negative 5. 4 take away 6 is a negative 2. 6 take away 4 is a positive 2. 8 take away 3 is a positive 5. And 12 take away 2 is a positive 10. So we have found our two numbers, 12 and negative 2. So this is where it's going to be a little bit more, it's going to be a little difficult. And it's all going to be because of this minus sign. you have to be careful with the minus sign. So I'm going to work this problem like I did the first example. I'm going to work it both ways, because there's something I want to show you in particular about this one. So let's take that 3x squared plus 10x minus 8, and we can rewrite it in one of two ways. You do not have to do both ways on your homework. I'm just showing you both ways. You have to do one way. So 3x squared plus 10x minus 8, we could rewrite that as 3x squared plus 12x minus 2x minus 8. Or we could rewrite it as 3x squared minus 2x plus 12x minus 8. So this one on the right is going to behave like the previous example. So let's do this one first. We're going to group the first two terms together, and we're going to group the last two terms together. And we ask ourselves, well, what's common? What do both of these two terms have in common? 3 is a prime number, 2 is a prime number, but they both share that x. So let's go ahead and pull out that x. Factor out an x. This first term would become 3x minus 2. This plus sign is going to drop down. And now we have to ask ourselves, well, what's common in both of these terms? Well, I could pull a 4 out of both of those terms, and that would leave a 3x minus 2. And we go, well, what's common? We got that 3x minus 2. And what's left over? We got an x, we've got a plus, and we got a 4. An x, a plus, and a 4 for our final answer. So, perfectly smooth. Went just like the previous example. If we work over here, we've got this minus sign. So, the process is going to be the same. We're going to group the first two terms, and then we want to group the last two terms. But consider for a second what happens if we had, say, negative x plus 4. And if we were to distribute that minus sign, that would give us a negative x minus 4. See how we can either subtract a quantity or we could subtract its parts? Right now we're subtracting parts, so when we go to group these last two terms, we would get a 3x squared plus 12x. We're subtracting the parts. Now we want to subtract the whole. Notice how that sign switched. You can always reverse this process. At this point, we could distribute that minus sign back into the 2x to get a negative 2x, and this minus sign back into the positive 8 to get a negative 8. You can always reverse your work when you're factoring. So be careful when you've got this minus sign, and when you group your final terms, the signs inside are going to switch. So once we're careful, and we're at this step, then it's just like this problem. We ask ourselves, well, what's common? What do these two terms have in common? Well, they share a 3 and an x. So let's factor out a 3x. That would leave us an x plus 4 left over. This minus sign is going to drop. That's that minus sign, and that's that minus sign. And we ask ourselves, well, what's common over here? Well, I can pull out a 2. That'll leave us an x plus 4. Perfect. So, what do these two terms have in common? Well, they got an x plus 4. What's left over? I got a 3x minus 2. Once again, these two are exactly the same. You can multiply in any order you want to. The trick is, be careful when you put parentheses in front of minus signs. When you got a plus sign, it behaves normally, but be careful with those minus signs. So we'll keep the ball rolling. Let us factor 18 x to the 6th minus 57 x to the 5th plus 30 x to the 4th. Okay. So we want to factor this thing. The first thing I notice is that all of our terms have x's. They all have at least 4 x's. So we can factor out an x to the 4th. We factor out an x to the 4th, we're left with an 18x squared minus 57x plus 30. Now, all of these terms, or all of these coefficients, are divisible by 3. So let's factor out a 3. That would give us 3x to the 4th times 3 times 6 is 18 x squared, and that would be 19 minus 19x plus 10. Perfect. Because 3 times 20 is 60, take away 3 is 57. Okay. So now we want to factor this thing. The 3x to the 4th is just along for the ride. Your job is to not forget to write this at every step. Now we want to factor this trinomial. So we'll do the same thing. 6 times 10 is a positive 60. And we're looking for the factors of 60 that add to a negative number, a negative 19. Well, I know negative 1 times a negative 60 is equal to a positive 60. I know a negative 2 times a negative 30 is equal to a positive 60. I know a negative 3 times a negative 20 is negative 20 is equal to a positive 60. I know a negative 4 and a negative 15 multiplied together to equal a positive 60, and I know negative 4 take away 15 is equal to negative 19. We have found the numbers we are after, negative 4 and negative 15. So now we can rewrite this problem. We know that we can rewrite 6x squared minus 19x plus 10. We can rewrite that as 6x squared minus 4x minus 15x plus 10. I think I said minus 10 a moment ago. And so we want to factor by grouping. We're going to, let's put parentheses here. Let's put 3x to the 4th out front. So we want to group this thing. This is going to look like this example with the minus sign in the middle. So we can group our first two terms without issue. 3x to the 4th. And I am going to switch to these big parentheses on the outside. I'm going to switch to a square bracket. That's just to make them visually distinct. And I'm going to put parentheses around the first two terms. So I'll get a parenthesis, 6x squared minus 4x. And now we're going to subtract. We are going to subtract. We want to subtract a positive 15x and a negative 10. And close that square bracket. Now the process is the same. We got a 3x to the 4th, a square bracket. We go, well, what can we factor out of a 6x squared and a negative 4x? Well, I can pull a 2x out of both of those terms. Get a 3x minus 2. And then we're going to subtract. Well, I can pull a 5 out of both of those. 3x minus 2. And now, like I said, this 3x to the 4th, just along for the ride. And we ask ourselves, well, what's common? That 3x minus 2. What isn't common? Or what's left over? 2x minus 5. For a final answer. You could write it without the square brackets. You could write this as 3x to the 4th times 3x minus 2 times 2x minus 5. Either or. This is what it looks like in the book. You can use as many parentheses as you want to. So, one final thing. When you're at this step, after you factor by grouping, if you don't have anything in common, double check your work. You are always supposed to have something in common. But only thing that was different about this problem is that all of these terms had a common factor of 3x to the 4th we could pull out, remember when I told you that if the problem doesn't have an x squared, an x to the 1, and a constant term, look for something clever. If all the degrees are high, or if all the degrees are greater than 0 or greater than 2, see if you can pull out some x's. Last time we also had some examples where the coefficients went like 4, 2, and none. So, like I said, when your exponents are different than squared, an x to the 1, and a constant term, look for a clever little trick. So, a couple more examples. 2 more examples, actually. Let's say we had 3 more examples. 3m, I'm sorry, 30 squared, stay over there, plus 23 mn minus 11 n squared. Okay. So we've got different variables floating around, but our process we're going to use is the exact same. We're looking for numbers. We're going to multiply the leading coefficient and the constant term. 3 times negative 11 is negative 330. So now we have to find factors of negative 330 that add to 23. So we can do, and I don't want to run through all of them. So we know that, it's going to be 33 and negative 10. 33 and negative 10 multiplied together to equal negative 330, and 33 take away 10 is equal to positive 23. So we can rewrite 30m squared plus, this is going to be a lot like this example. Oops, I lost it. Is going to be a lot like this example, how we could write it one way where there's a minus sign in between these two terms, and another way how there was a plus sign in between those two terms. So I recommend, and I always have recommended, that students try and put a plus sign in between their two terms just because it's easier. There is one more step in this process where you guys can make a little mistake, so when at all possible, I try and avoid that situation. Keeping that in mind, I want to rewrite this as 30m squared, and I want to write minus 10mn plus 33 mn minus 11n squared. Get out of here. Yeah, you. So, same thing. Group the first two terms, group the second two terms. What's common between these two terms? Well, I can pull out a 10m. And what's left over, we'd have a 3m minus n. This plus sign is going to drop. And we ask ourselves, well, what can we pull out? We can pull out an 11n. That would leave us 3m minus n. We ask ourselves, what's common? 3m minus n. What's left over? 10m plus 11n. I skipped over the wonderful work of figuring out these factors. If you guys are getting stuck, what am I doing when what am I doing when I find these factors? I'm asking myself, does 1 divide 330? Does 2 divide 330? And so let me give you a hint. We'll work this one out. So the mathematics behind the scene that got me to those numbers. Negative 330. Well, I know that 1 goes into that number. That's just kind of a gimme. That's an easy first step. I know that that number's even. It ends in a 0, so 2 has to go into it. And then I divide that number by 2. That would give me a negative 165. 3 would go into that number. That would be 3 and negative 110. Now I ask myself, does 4 go into that number? Well, if 4 goes into negative 330, that means 2 would have to go into negative 330 twice. Well, when 2 goes into negative 330 once, it equals negative 165. That's an odd number, so I can't divide it by 2 again. So I know 4 does not divide that number. 5, it ends in a 0, so 5 will definitely divide. That would give us a negative 66. Once again, I get that number just by brute force mathematics. And then 6. Well, if 2 divides negative 330 and 3 divides negative 330, that means 6 has to divide negative 330. And 6 would divide in 55 times. Negative 55 times, I'm sorry. 7, you just have to check by brute force. Didn't work. 8 isn't going to work. 8 would work if 2 and 4 worked, but since 4 didn't work, we know 8 isn't. 9. A trick for 9, if the digits of a number sum to a multiple of 9, then that number is divisible by 9. This is not. 10 is fairly straightforward. 10 and negative 33. If you've noticed, there is a point when these numbers, the numbers in the left column, start appearing on the right. That happens in between these two lines over here. 1, 2, 3, 4, 4, 3, 2, 1. It's always going to count up to a point and then count down. So that means I know that if I've got a 10 and negative 33, I'll eventually have a 33 and a negative 10. And I know 33 take away 10 is equal to that 23 I was after. So you don't have to guess all of them. I typically run through the entire list because I'm trying to teach you something. I'm trying to show you, and I feel compelled to finish that as 23 now that I'm looking at it. I'm trying to show you absolutely everything, so if you get stuck in a certain part of the process, you've seen the whole process. You can work some, notice something, and then skip around. You do not have to provide an entire factor tree. Something that might help you is a prime factorization. If you look up the prime factorization for a number, it'll tell you all the prime numbers that divide it. You can also just use your calculator. You can type in 330 and you can divide it by 1. You can divide it by 2, 3, 4, 5, 6, 7. You can test every number. You're only looking for the integers. You're only looking for the nice whole numbers that multiply together to equal negative 330. But the process is the same even if the numbers get a little bit bigger. Look up prime factorization. You guys can use a calculator. That might help you. But yeah, the process was largely the same. So let's factor. Let's factor 6x to the 6th plus 23x cubed plus 20. And so this one doesn't have an x squared, but if you notice, 6x to the 6th, that's the same as 6x cubed squared plus 23, I'm going to put it in parentheses, x cubed plus 20. So we've got something squared plus something plus a constant term. We can factor this. And importantly, we can factor this with the AC method. Sorry, my cat is attacking things. So, first number times last number. 6 times 20 is 120. Factors of 120 that sum to 23. You got a 1 and a 120, 2 and a 60, 3 and a 40, 4 and a 30, 5 and 24, 6 and 20, 7, 8 will do it, 8 and 15. Yeah, 8 and 15. Yeah. Okay, and 8 plus 15 is equal to 23. So we write this polynomial, trinomial, plus 8x cubed plus 15x cubed plus 20. Once again, could have written them in either order. Group the first two, group the last two. What's common? I can pull out a 2x cubed from both of those terms, leaving me a 3x cubed. 3x squared plus 4. And then, nope, I was right. 3x cubed. Sorry about that. 3x cubed plus 4 plus, and we ask ourselves what's common over here. Well, I can pull out a 5. 5 times 3x cubed plus 4. What's common? 2x cubed plus 5. Well, I guess I normally call that what's left over. So what's common? 3x cubed plus 4. And what's left over? 2x cubed plus 5. Like I said, you can do these in either direction. 6x to the 6 plus 15x cubed plus 8x cubed plus 20. We group. I can pull a 3x cubed out of both of those terms to get a 2x cubed plus 5. And then what's common? We can pull out a 4 plus 4 to give a 2x cubed plus 5. What's common? 2x cubed plus 5. What's left over? 3x cubed plus 4. They should definitely be the same. So let's give you one final example. Let's say we had a 6x to the 4th minus 116x cubed minus 80x squared. 80x squared. And so I notice that we got an x to the 4th, we got an x cubed, and we have an x squared. I also notice that all these numbers are even. So I'm gonna pull out a 2x squared to begin with. That would leave us with a 3x squared minus 58x minus 40. Just minus 40. Now we're looking for numbers that multiply to negative 120 and add to negative 58. Well, we're going to have 1 and negative 120, 2 and negative 60, 3 and negative 40, 4 and negative 30, 5 and negative, and we already did all this work actually, back here, 5 and negative 24, 6 and negative 20, 7 didn't work, 8 did, that was 8 and what, 15? Negative 15. Do any of these equal? Yeah, this one does. I got excited. Equals negative 58. I was more worried about factoring 120. Lost sight of the goal. So, we can rewrite this in one of two ways. I'm going to recommend you rewrite it in the following way. And I like to put brackets at this point. 3x squared. I like to put the negative number first. Minus 15. I don't know why I pointed there. 2x squared. I like to put a bracket. 3x squared. Now we're going to write negative 60x plus 2x minus 40. I always write the negative number first when we have a negative and a positive. That way I can group these. I'm just trying to avoid having a minus sign. Sometimes it is impossible to avoid having a minus sign there. Like when this is a positive, or when that's a plus sign and that's a minus sign, you'll have two negative numbers down here. But if you have two positives, it's easy to have that be a plus sign. If you have a positive number and a negative number, I put the negative number first. If you have two negative numbers, it doesn't matter. You have to deal with that minus sign. 2x squared, we're just trying really hard not to forget to write that. Bracket, I can pull a 3x out of both of these terms. 3x, that would leave us an x minus 20. This plus sign is going to drop down. I can pull a 2 out of both of those. And bracket, write this 2x squared again. And we go, well, what's common? What do they share? They share that x minus 20. And what's left over? 3x plus 2. For our final answer. So, like I said, this process, this is the exact same thing we were doing last time. We just added one step to it. We're still multiplying. Before we were taking, so I keep saying that kind of without explanation. If we were to say multiply, if we wanted to factor x plus x squared plus 8x plus 15. I was telling you to consider the factors of 15 that add to 8. Well, x squared is the same as having a 1x squared, and if we were to multiply the last number and the first number, we'd get 15, and the factors of 15 that add up to 8. Well, that'd be 3 and 5. So we could rewrite x squared plus 3x plus 5x plus 15. Factor out an, well, we'll group these terms. Factor out an x. Factor out a 5. What's common? What's left over? So, getting to right here, we've been doing. We did last time. The only thing that changes is we're rewriting this middle term in a clever way. Once you know the numbers, it doesn't matter which order you write them in. Some might have easier algebra than others, but it doesn't matter. You can just rewrite it. And like I said, all we do is rewrite the trinomial. Oh, for homework, and these do take some practice, go off and do 1 through 49 every other odd. Don't do every odd, that'd be a lot of work. Do every odd if you want to. Don't let me tell you what to do. You can do what you want. But yeah, factoring, this is about as bad as it gets for factoring trinomials. There's a lot of stuff out there that you can't factor. A lot of irreducible quadratics, as they call them. Even those can always be factored. You can write any trinomial as ax plus b times cx plus d. Any trinomial can be written like that. They might not always be real numbers, though. I need to throw that out there as a little caveat. But yeah, AC method, multiply first number times last number, factor that product, find numbers that add to the middle term, rewrite your trinomial, group the first two terms and the last two terms, factor by grouping to get to your answer. Go off and do that homework. If you guys have any questions, shoot me an email. Take it easy. Hope you all stay healthy. Bye-bye.